And with that, I am pleased to introduce our two presenters, Dan Fernback and John Thompson. Dan is the Vice President and co-founder at Juggerbot 3D, and John is an applications engineer with JBM Technologies. And I'm going to first turn it over to Dan.
Thank you, Molly. Can you hear me okay?
Yes.
Very good. Well, good morning, everybody. Thank you guys for joining us. As Molly said, my name is Dan Fernback. I'm one of the co-founders and vice president of Juggerbot 3D, and we manufacture industrial grade 3D printers in Youngstown, Ohio. We've been in business since 2014 and have since helped manufacturers to leverage 3D printing for functional applications using our proprietary filament and pellet-based extrusion technologies. But enough about us. 3D printing is a fast-growing manufacturing technology with the potential to disrupt the way engineers design, how manufacturers produce, and even the way businesses function. There are already 3D printers in laboratories, on shop floors, and even in households. Still, we know and understand that it can be a daunting task for folks in the manufacturing industry to get started with 3D printing. It's been around for a long time, and it's been growing rapidly over these past 10 years. But why do we want a 3D printer? How do we justify paying for one? And how do we support a 3D printer are all common questions that we get. So for the next 20 minutes or so, we're going to dive into what makes a good 3D printing application, the 7 different types of 3D printing techniques, 3D printing applications and the impact they can have for manufacturers, and then the benefits your company can reap from 3D printing. First and foremost, 3D printing refers to a whole family of processes, making physical objects from a 3-dimensional digital model by adding layer on top of layer. This is why it's also referred to as additive manufacturing. Every 3D print starts with a 3D model. 3D models can be designed using CAD software like SolidWorks, Fusion 360, or even Tinkercad. They can also be obtained from a 3D scan of a real-life object, and they can even be downloaded from some websites that offer that service. Those models are then loaded into a slicer, which is our CAM software, where they're sliced into thousands of layers, and then each layer is converted into G-code, which is communicated to the printer. The G-code commands the printer to move in certain positions at specific speeds, as well as where and how much material to apply. 3D printing is used in every industry under the sun, at least to some capacity. It's playing a role in how all of us travel, whether that be by water, sky, rail, or pavement. It impacts how clinicians take care of patients. It's used to build the systems that deliver critical resources like water and oil. It was probably even used, at least in some way, to help produce the appliances that you use at home every day. But how can it help you and your team specifically? Simply put, you have to start by identifying an application right for 3D printing. Just as its framework lays out, application drives everything in 3D printing, which technology stack you use, the impact it can have on your operation, and the benefit your company should expect to see. So the best way to start is by knowing what makes a good 3D printing application. And the best applications are those which align best with 3D printing's strengths. There are a handful of advantages that 3D printing offers over other manufacturing technologies, which makes it exciting and poses a disruption to how things are made. One of which is design freedom, enabled by the additive process. Because you are building parts layer by layer, you can create geometries that are literally impossible to make with other manufacturing processes. Therefore, 3D printing is generally desirable for more complex or hard to make designs. Another benefit of 3D printing is the fact that you can make parts on demand. As we discussed, making parts with a 3D printer can be as simple as uploading a 3D model into your slicer, exporting your G-code to your printer, and pressing start. So why did I include a picture of one of the greatest heavyweight boxers of all time? Because Mike Tyson gave a great quote heading into a fight with Evander Holyfield that goes, "Everyone has a plan until they get punched in the mouth." The same is true in manufacturing. If you have time to prepare, and if everything is going to plan, you don't necessarily have to worry about being on demand. That kind of skill set becomes very critical when things don't go to plan, when you can act fast in the face of adversity. You might also realize that the 3D printing process does not require specific tooling like molding or casting or even machining does. Tool-less production supports a strategy revolving around the concept of mass customization, where production orders can be profitable at higher mix, lower volume ratios than with conventional manufacturing. All right, now that we know the strengths of 3D printing, we can start to define the specific areas within our businesses where common problems can be solved using the technology. 3D printing has been used to make prototypes for more than 30 years. And while it's a great tool for teams to rapidly produce early models of their designs, prototyping is really just the tip of the iceberg for 3D printing. In fact, many companies are already deploying 3D printing to do way more than just prototypes. Manufacturing aids like assembly fixtures and work holding are also a great entry point for 3D printing. Even production tools like patterns for sandcasting or molds for thermoforming can be a great place to use additive manufacturing. And the same goes for gauges, CMM fixtures, or other quality instruments that need to be artfully crafted to support the operation during or after production. Spare parts are another key application. We've even seen entire spare part design and management strategies being driven by 3D printers that are strategically located in certain proximity to the end user. And finally, more companies than ever before are pursuing novel production programs as the scalability of 3D printing rises through innovative technologies and techniques. So after we identify what seems to be a good application for 3D printing, we have to find the right 3D printing technology stack to implement. There are actually 7 different types of 3D printing techniques recognized today, and many contain multiple sub-techniques. So moving left to right, we'll touch briefly on each one. Printers that make plastic parts by using light to cure photopolymers often fall under the vat photopolymerization umbrella, including popular sub-techniques like SLA and DLP printing. Powder bed fusion, on the other hand, can make parts out of plastics, metals, or ceramics by melting and fusing powdered material with a laser or electron beam. Binder jetting also makes parts from powder or sand, only the process involves selectively depositing a binding agent onto the powder in a specific path, and then after that part is solidified through post-processing. Material jetting is a process that makes 3D objects by curing material that is jetted from an inkjet light using inkjet light head using UV light. Sheet lamination is a process where sheets or ribbon is cut into specific shapes, replicating a full layer, and are placed one on top of the other, and then are bound together through welding, heat, or adhesive. Direct energy deposition is primarily used for metal and creates parts by applying material directly onto the surface of another part, where it adheres to the underlying surface by applying energy from a laser, beam, or arc. And finally, there is material extrusion, which is one of the more prominent 3D printing techniques. This is where you find filament-based 3D printing, which you've probably seen at some point in time, creating parts by drawing material through a nozzle and selectively depositing it on a predetermined path, of course, making parts layer by layer. So each of these techniques has its place, and your teams can effectively sift through these options by focusing on a few key variables. For instance, material requirements can refine your option by knowing if the 3D printed parts need to be made from metal, thermoplastics, or photopolymers. In cases where a single additive manufacturing technique can process multiple material families, chances are that specific differences exist between the processes to do one material versus the other. Material extrusion, for example, can produce parts with metals or thermoplastics using filament. However, the material extrusion process to make metal parts requires debinding and sintering, 2 steps that aren't required when printing plastics. Part size is also a way to narrow down the optimal 3D printing solution for you. Some techniques, like material jetting, are really good at making small parts that can fit in the palm of your hand. Others, like sheet lamination, are a good fit for medium-sized parts like furniture or dunnage. And a few, like material extrusion, can print small parts, medium parts, and large parts, like the mold for a boat hull. A third way to navigate the 3D printing waters is by accuracy and precision. Do you need tolerances right off the printer to be plus or minus a few thousandths of an inch, or can your application allow tolerances that are plus or minus a couple, like an eighth of an inch or a couple millimeters? Is the minimum feature size less than a millimeter or more than a millimeter? It's kind of difficult to actually show a navigation in this way for accuracy and precision, as it requires input regarding the technique, the specific machine, the slicing parameters, and the material. But you can use this graph for guidance and should verify as much as you possibly can with your vendors, with your suppliers. A fourth way to navigate is by cost. And even though there may be some outliers in the machine and material cost, for instance, a desktop unit or commodity material, equipment, materials, and utilities are just simply more expensive for some of these techniques than others, so that'll help. This is not an exhaustive list. Obviously, there can be some changes depending on your specific application, but it is a starting point. And it can be sliced in different ways, for instance, by filtering only for machines under a certain dollar amount or by a specific material. It can be built on to include additional drivers as needed. After you've identified a potential application and narrowed down the techniques suitable, you'll want to evaluate the impact and benefit expected from your 3D printing solution. For this case here, and for clarity, impact is referring to the change, the influence, or the opportunity that's enabled by the technology, while benefit is referring to the effect, the consequence or outcome, kind of like the bottom line. So here are a few notable areas in your business that will be impacted by 3D printing. Tooling cost, specifically the elimination or reduction of tooling cost. The time it takes to launch a product or program, so your product development timing. Your team's flexibility, their ability to respond to changes and be agile. The efficiency of your operation, new business opportunities that you can pursue. The design and performance of your parts and or processes, and finally, the lead times for you and or your customers. We generally start by identifying one key application to get manufacturers started with 3D printing, focusing on whatever impact is addressing their primary pain point. But oftentimes, the 3D printing application will impact the business in more than one way. The reverse is also true. Different 3D printing applications can also be used to have the same or at least similar impact on a business. So take the impact 3D printing has on tooling costs, for instance. 3D printing can be used to eliminate tooling altogether in many prototyping applications. It's also proven to be a more cost-effective way to produce manufacturing aids, especially for assembly operations and automation. Where production tooling can be printed, you're obviously not eliminating the tooling cost, but manufacturers can see huge cost improvement. For instance, we've seen foundries saving 50% on average when they bring on Juggerbot 3D's technology for patterns, core boxes, and masks. We've seen a similar impact when companies use our technology to produce custom quality instruments. I mentioned earlier that some companies are totally refining their spare part strategy to center on 3D printing because it not only saves them the upfront cost, but down the road, they won't have to worry about refurbing or replacing old tools. And finally, if you head into a production program that uses 3D printing as the primary manufacturing means, then obviously no tooling is required. So now we have the payoffs, right? The return you get when you successfully match application and technology, the results of the impact your 3D printing solution has on your business, so the benefits. That includes better product performance, increased team morale and motivation, less risk, happy customers, and financial gains. So to dig into those a little bit deeper, by better product performance, I mean things like better strength to weight ratios or consolidation of parts in an assembly. I mean, customers that are thrilled to work with you because you bring them innovative solutions in a timely fashion. I mean, a team that feels valued and energized because their company's investing in tools to empower them, which also serves as an exciting draw for new employees. And ultimately, we mean having better control over unknown circumstances and seeing higher revenue and better bottom lines. So I'm going to hand it over here to John in a minute, who's going to share a 3D printing use case that he personally experienced and demonstrate some of these items. But first, Molly, are there any questions?
There are no questions. There was someone that raised their hand and it popped off, so I don't have their name. But whoever that was, if you want to put in the chat box what your question is, and we can address that. But no current questions, Dan.
Thank you.
Okay, so we'll just take a minute for John to bring up his presentation, and John will kind of carry us through the latter half of this presentation. And that looks good, John.
All right, can you hear me all right?
I can, but you hit something and now it's showing the preview.
Yep.
There
Yeah, I
we
was,
go.
yep, okay.
Now we look good.
All right, so hello, everybody. I'm John Thompson from JBM Technologies. If you haven't heard, we're your source for machining and technology solutions. So we've been in business for 35 years or more, actually, by now. And we're the proud distributor of some of the world's best machinery. So there's some familiar brands you may have seen before on there. You'll note that Juggerbot 3D is on the top line there as well. So we spent quite a bit of time sourcing the most premium additive manufacturing machine on earth. And fortunately, they were already in our territory. So that's great. If you live in these states, you can see this is our territory. So I personally am located out of Ivyland, but we have coverage in all of these regions, and we'll travel to suit as need be. And today I'm going to go over a real world justification for 3D printing involving the Juggerbot machine. And if you're new here and you haven't seen some of our other videos, we have some other ones as well. So today's going to be a very specific rundown on a stop loss problem in a business. So let's get right to it. So we're going to talk about bottom line up front, how I fixed a problem with 3D printing that was a six-figure problem. So whenever something breaks in your factory, do you want your business to lose tremendous downtime from lost revenue, affect all the key players, lose opportunity, the sales in general, most importantly, reputation with your customer? Or by using 3D printing, do you want to only lose approximately $9,000 and get along with your day? So the answer there is obvious. So, okay, let's scroll up here. So first, let's lay out the problem. So in my prior career, I was a vice president of engineering for a production machining company. It was my responsibility to ensure consistent output of product, quality, et cetera, and management of the staff. So a typically reliable CNC screw machine began leaking cutting oil on the floor. Now, usually this would be something like operator negligence with a drain hose or chip buildup or something like that. So the usual routine follows. People find an oil leak. Okay, let's go take a look, see what we're dealing with. As soon as you stop the machine, the clock starts ticking. So every minute that machine's not running, you are losing revenue. So after some amount of time, they say, okay, let's find some mops, get this oil off the floor, and let's start locating the source of the leak. So after some looking, turns out that a turret seal, a very simple piece of plastic with a few tight tolerances and basically a wear item, it slides inside the tube of the turret and seals the liquid inside the machining cabinet. So we see that this was torn. So torn seal. So, okay, oil's getting through into the back of the machine and then running out onto the floor. So after consulting the immediate supervisor, I was informed of the issue. So the machine stops running. Okay, it's my responsibility, so I'm aware. So usually with this type of equipment, this would be a frustration of just ordering a spare part from the local parts department, getting back into production the next day. You ship the product UPS red, you get it in there. Okay, time marches on. But we had a serious problem with this. This part is supposed to have an indefinite lifespan. For us, it was wearing out. The product was not in stock and had an 8-week minimum lead time from Japan to be manufactured. So here's where it gets interesting. 8 weeks to wait for a part. The machine is down. What are we going to do? So with the machine down, we were losing $2,919 in sales per day. At 5 days a week, this loss of revenue would be about $116,760 while the part arrives. So let's say that again. Without this part, the company is going to lose $116,000. So by lunchtime, the entire management chain of the company is involved, and we are mostly in a panic at this point. So here's what happened. Machine goes down. We find the source of the problem. When we realize what we're up against, by the time lunchtime comes around, the entire chain of command is affected. I'm the vice president here, so my supervisor reports to me, the machine operator, maintenance crew, purchaser of materials and parts, idle staff. You can see the whole layout here. So obviously lost revenue is your primary concern for the business at the immediate state. Customer frustration is unacceptable. So what we did was we investigated outsourcing this part. We can't get it from the factory, so let's just make it, have one of our friends make it, one of our neighboring businesses, etc. So checking around, we were able to find somebody that can make it in about half the time that the Japanese supplier could make. While losing about half the time would be about $58,000 in lost revenue. So by this point, our company president is on the phone with the machine tool manufacturer and distributor to try to escalate the situation. No luck there, as this part is supposed to last forever. So meetings are held. What do we do? All hands are on deck. We're in a situation. So let's try to make it in-house. We're a machine shop after all. But we are a production machine shop. We did not have a fully equipped tool room. But regardless, we are not going to accept losing 5 to 6 figures of revenue. That is unacceptable. So can we make it? Somebody's at this point quoting materials. Do we have UHMW? Do we have nylon, Delrin, Teflon? Is there anything in stock that we can make this out of? Okay. Meanwhile, everybody is aware that we're going to be losing approximately $5,000 a day. We find one machine in the shop that can actually locate, that we can fit this product in to make, but that unit makes even more money per day. So we can't stop that one either. So we reconvene with meetings to say, okay, what are we gonna do? We can't buy it. We can't make it in-house. What are we gonna do? So the 6-figure question, what do we do? Well, we're gonna 3D print this thing. So take a moment to sit back and hear how this plays out. For a hypothetical, let's suppose we had a well-equipped tool room to make this. We would CNC machine this part in-house, time and materials plus overhead costs. We could do okay there. Say in a day's time, a good tool maker can go from start to finish with an urgent pace. By the end of their shift, the finished repair part is ready. However, since the tool maker always has a backlog, the repair part needs to be designed and approved. Let's say the fastest we can get the part into that is the next day, maybe the following. So we're still waiting. The machine is still down. We're losing $5,838 in sales per day. So we have people rushing around. We're shopping for material, double checking things, rush shipping, reacting, panic, etc. Best case scenario, if we can get our tool room maker to do this, we will lose $12,700. Average case, let's say 20 grand. By the time things get in there, stuff happens, people switch shifts, etc. So best case, if we're making this part with traditional methods, we're going to lose $12,700. But what about opportunity cost? How many hours did we just spend dropping everything for this? How much distraction and panic? The entire company lost visibility for a whole day. Beyond cost, what is the effect this much stress has on the crew? So what do we do? So we're going to 3D print this. So our company had a secret weapon to fix this. A decade ago, when 3D printing was still considered a toy technology, I was the guy bringing it into our production shop. At this time, I was building custom printers and making real parts regularly at approximately 90% less the cost for the metal product. I had this part designed and printing within 3 hours. It's a basic shape, decent tolerances, few considerations beyond material choice. Fortunately, I kept a supply of nylon in hand for just such an occasion. The part was just big enough, just flimsy enough, and required just enough accuracy that printing was the only easy button available. The part was finished by the end of the day and installed the next morning. So as you can see here, this would be the typical idea from large, small machine shops. Maybe the engineer and the maintenance person is the same person, who knows? But in this case, as opposed to having everybody in the chain of command affected, in the future, all of these problems were solved by having the maintenance person, the engineer, who in this case was me, and a 3D printing machine to solve these issues. So we're back in business. By the end of this, we lost 1.5 days of production. We lost the wages to have myself design, print, and install this item, and the material cost to print the item. To print this seal was $2.66 in solid nylon. That is a negligible cost. We lost approximately $9,300 turning this machine back into production. At the onset of this day, this problem was going to cost us over $100,000 in lost revenue if we would have waited for this part to arrive from Japan. If we'd have made it ourselves, maybe we'd have lost $20,000. By 3D printing, we were back in business, we lost $9,000. So all the machine shop folks here, all the production people, that kind of revenue is easily made up. That's a Saturday, that's a little bit of overtime. Most importantly, by the end of the month, the customer wasn't affected. They got their orders on time. We were able to recover easily, and the panic was reduced in the shop, and everything went back into business. So while this was running, we ordered up the repair part and put it on the shelf so we could operate that in a controlled function. Expecting the printing part to fail, we had assumed that by the time the new part would get here, all's well, we could replace it in a reasonable time. But this part lasted several years. So at the end of the several years, we put the replacement part in, the new one from the factory, and again, crisis is averted. The other thing we chose to do was 3D print a spare to put on the shelf. So that's where the full circle comes with all of this stuff. So machine goes down, we repair it ourselves, we source the replacement part. Turns out our 3D printed part was just as good, if not a little bit better than the original part. So we no longer purchased that part to stock. We just made them and put them on the shelf at a cost of $2.66. So let that sink in for a second. Do you want to lose six figures or do you want to lose just a couple thousand? So with a controlled and planned approach to the repair, we completely averted the crisis. So this is what Juggerbot 3D and JBM Technologies brings to the table. So we have solutions for these types of things. And we feel that if you give us a chance to impress, we're confident you'll succeed and find new ways to take your business to the next level. With that, we expect over the next several months to show not only how we've solved major emergencies like this, but talked about improving our today situation and then how we can add value for tomorrow. So we're going to break for some questions in a moment. And I guess Molly and Dan, is there anything that you wanted to jump into and really dig into now before I continue on a little further?
We don't have any questions at this time, so I'll remind everyone to go ahead and use the Q&A box to ask the question, or if you're more comfortable using the chat box, that's okay as well. And we'll address those questions at the end of the presentation. But there are, as I said, currently no questions. I don't have anything to add, but Dan, if you do, feel free to chime in.
Not at this time, John. If you had more you wanted to get into, please proceed.
Yes, I do actually. So that said, these scenarios will look different for everybody. And originally we were going to put up some spreadsheets to try to line item what the return on investment, the kind of costing that would be associated to really justify buying this type of capital equipment. So if you're looking at like a Juggerbot filament machine, the F332, you have to look at what that costs and what you're going to gain. The amount of money we saved in just this one instance almost paid for that Juggerbot machine in one swing. So without even getting out a spreadsheet, without even taking the opportunity cost to really eyeball what this looks like, we were in and out of this problem and solved. And the next time that problem comes up, now we're cash positive on that unit. So now I know it's complicated. You can spreadsheet it up one side and down the other, but you don't need to even calculate that when you're looking at this type of stop loss. And then whenever you start to look at the opportunity of what kind of gains you can get out of this by making things like CMM fixtures, tooling, material handling, actual machining fixtures, we were able to machine products held by 3D printed parts to 4/1000ths of an inch tolerance total, not plus or minus 4, plus or minus 2/1000ths, 4/1000ths total. So when you start to really look at these things and you say, well, how is that possible? Are we really there yet? The answer is yes. We're at the future and the future is now. So now the real issue is, how does a machine shop or any type of business really compete against a place that now has one of these 3D printing machines that has the control over their business, has the control over their machine uptime, reduces the complexity of their own supply and vertically integrates. How do you compete against that when the future is now here and your next door neighbor has it and you don't? So there is a strong impetus to keep going into the future. And with all these justifications, this was what we were doing 10 years ago. I can't even imagine what it's going to look like 10 years from now, but the future is now. So we're proud to be a part of it. And with these Juggerbot machines also comes the knowledge and know-how of how to put these into the factory and make them work. So that's what I'm trying to bring to the table for all of us here. And really, we just want to add value to our customers and make our lives easier and just get on with the production and with the show. So that's all I had here. I know these questions can go any which way. Feel free to contact me, however. And just wanted to say thank you very much. Appreciate your time.
Great, thank you, John. I believe Dan has a final thought while we still do have time for questions if anyone wants to type those in.
Yeah, I just wanted to really echo John's final statements there. There's never been a better time for manufacturers to get into 3D printing than right now. I think statistically speaking, a lot of more manufacturers than not are already using 3D printing for something. I just read a recent article in PwC, PricewaterhouseCoopers, about the applications, and there's still a lot of tinkering going on. So to John's point, 10 years ago, you would need maybe a more forward-thinking, talented group of individuals to make good use of 3D printing, but so much has progressed over the past decade that it's now something that is more viable for all manufacturers in one way or another, right? So there's never been a better time to get a part of it. And I think for most people on this call, there is plenty of local support to help folks successfully enter the field of additive manufacturing, whether that be through NWIRC and organizations like that, JBM Technologies, or even OEMs like us at Juggerbot 3D.
Great, thank you, Dan.